case. So I'm going to draw another normal curve here. All right, so I'm going to draw another normal curve. And I have my pretty normal curve here. And I have the normal curve mean. The mean is here. And one standard deviation above the mean is 118. And this question says, what percentage has 118 or above? So I already know that the total of this is 50%. Okay, and here I have half of 95. So since this is 1/2 of my 68%, 1/2 of 68% is 34%. So this is 34%. So what I'm going to do is 50 minus 34. 50% minus 34, and so I will have 16% right here, only 16%. Okay, so we can actually, because you're allowed to use your calculator, you can do this using your graphing calculator, and so you will not make any mistake. So I'm going to go back to using calculator to actually make sure that my answers are correct. So we're going to write the argument. The argument, before I write the argument, I want us to know that our calculator does not understand infinity, but this tail is going to negative infinity and the right tail is going to positive infinity. So I want us to know that whenever it goes to negative infinity, you will key in your calculator negative 1e to power 99. That is infinity. On the right hand side, you have positive 1e to 99, positive infinity. Okay. Anyway, so I'm going to get my calculator and I want to actually make sure we know that this is going to be normal cumulative density function. And the argument is lower bound, upper bound, mean, standard deviation. So that is how to calculate the area under the normal curve. So we want to actually show that the empirical rule is correct, but the normal curve is more accurate. Using my calculator is more accurate. So I'm just going to pull up my calculator and try to answer those questions again using my calculator. Using my calculator, I'll answer the questions. All right, so I am going to pull this up. And then we will go back to the question. And we are using the calculator this time. So and then we are told that, by the way, where do I see normal CDF? Second distribution, the normal CDF. And by the way, what is normal CDF? C means cumulative, D means density, F means function. So normal CDF is cumulative density function. So number 2. So let me go back and make sure you know how I got there. So I'll go to second verse. I choose number 2. The lower bound is what I have to put here. So in question number 1, I'm using raw data. We have not even calculated z-score. So I'm not trying to do z-score here. I'm just going to use raw data. My calculator is so sensitive, it can use raw data. It can also use standardized data. So I am going to put the raw data on the left-hand side. In number 1, the raw data is 82 because 82 is less than 118. The upper bound is 118. The mean is 100. We're using raw data because we have not done z-score. All right. The standard deviation given to me is 18. You see, we are using only raw data. And so we want to verify our empirical rule. Is that answer we have true? In other words, is the area under the normal curve within one standard deviation equal to approximately 68% according to empirical rule? So I'm going to ask my calculator. I will paste, enter, and it's asking me, is this what you are asking? Is your lower bound 82, upper bound 82, mean 100, standard deviation 18? And I'll say yes. It calculated it to me. And my calculator tells me that the area between 82 and 118 in that question is actually slightly greater than 68. Because my calculator is more accurate, you are advised to use your calculator most of the time. Leave your answer to 4 decimal places. If the question specifically says use empirical rule, then my lab maths will not mark you wrong. But if the question did not say, use your empirical rule, then be careful. You need to use your calculator because your answer to 4 decimal places is 0.6826. 0.68. Okay, so according to my calculator, I have 68.27% is the area under the normal curve within one standard deviation. Let's do the same thing for area to the left. Remember we got 2.5%. Let's do the calculation using our calculator. So I'm going to use second distribution, number 2. This time I am calculating area to the left. Let me draw it again so you know what I'm calculating. Area to the left is what I'm calculating. So this area is from 64 to negative infinity. Of course, negative infinity is not in the range, but I have to use negative infinity. And what does negative infinity mean in a calculator? Negative 1 e to power 99. Negative 1 e to power 99. I will clean and do that again. How do I put in negative infinity in my calculator? It is negative in parentheses 1. Where do I see E? I'm recording this. That way you can go back and see it again. It's in the textbook. The textbook showed it the same way, to power 99. Why am I doing this? I'm calculating area to the left. Anytime I'm calculating area to the left, I am using lower bound and upper bound. So this is 64. And the mean is 100. The standard deviation is 18, and then I will paste. When I hit enter, it gives me approximately the answer I had. The answer I had was 2.5%, approximately 0.025, yeah. So this area is 0.02, actually 3. So remember that your calculator is more accurate. If you leave your answer to 4 decimal places, you have 0.0228. 0.0228. Okay, let's do the same. Of course, we don't have to, because this answer I just have area to the left is going to be when I do it to the right. So let's find area to the right, so you know that the normal curve is symmetrical. Normal curve is symmetrical, so when you calculate area to the left, it's going to be the same area to the right. But because we're doing it for the first time, let's calculate area to the right. Well, what I'm doing this is because you will be expected to use your calculator to answer other questions with normal distribution, especially now we haven't done z-score. When we do z-score, we shall actually use z-chart. And you can use both z-chart and your calculator also. Okay, I'm calculating area to the right because and B asked us to calculate area to the left and area to the right. So I'm going to do that. Area cannot be negative, so area will never be negative. So for the area to the right, I'm going to do second distribution again. Number 2, because it's area to the right, it is 136, because 136 is lower than positive infinity. Down the positive infinity here, I want you to look up here, look here and see what I'm saying. Right here, this is 136. And then positive infinity is 1e to the power 99. And when I get my calculator, I will just put in 1e to the power 99. 1, where is my e again? Second e, I want you to see that e is above comma, to the power 99. The mean is always 100 in the same question. Standard deviation is 18 in this question. And I'm going to calculate. When I hit enter, I got the same answer. So area cannot be negative. The normal curve is symmetrical. So if you can calculate the area on the left, because the normal curve is symmetrical, then it is the same as the area to the right. So that's about number 2. Now we're going to do area greater again, because you don't have to do empirical rule actually. If you don't remember empirical rule and it is exam and your time is passing by, or you have probably forgotten empirical rule. If it's a final exam, you probably forgot what empirical rule means. By all means, use your calculator. So question number 25C says calculate the area greater, area to the right. So let me try my whiteboard and see if this is going to work, because it's like I'm writing so much. So let me try my whiteboard and see if it's going to work. Let's come here. Clean this a little bit. And I'm going to clean here. This is cleaning better than. All right, so this question says find area to the right. And to find area to the right of 118, I still remember the information. And so I am going to, let me use the black. So I'm going to draw the normal curve. And this normal curve has mean at the center. And 118 is here. And I'm looking for area to the right. So I shade the right, and the standard deviation is 18. And the argument is normal CDF, normal, use that right now, normal CDF, lower bound, upper bound, mean, standard deviation. Let me just write the standard deviation here. All right. Standard deviation. Come on. Excuse me. Okay, so what is the lower bound here? 118. But let me just look and see what actually was the lower bound. I want to make sure that we're using the, okay, 1C says lower bound is 118. So 118 upper bound is positive infinity because I'm calculating area to the right. Positive infinity, 1e to power 99. If you type infinity in your calculator, it will say quit because it does not understand infinity. The mean is 100. Standard deviation is 18. Okay. Normal CDF. Let's use a calculator again. So we go to our calculator and find the area to the right with our calculator. I'm going to clear all the other ones. So second distribution, number 2, area to the right. And the lower bound is 118. The upper bound is infinity, 1e to power 99. So I still have it here. I don't have to clean it. Maybe I have to clean this. So let me do it again. I want to clean it so I can type it again. So you see it. 1e to power 99. Where do I see E? Second, comma, E is at comma to power 99. That's infinity. But my calculator does not understand infinity. The mean is 100. Standard deviation is 18. It doesn't take all this time. It's just because we're doing it for the first time. And so when I hit enter, I'll find area to the right. And that area to the right is 15.87% to 2 decimal places. If you're told to write your answer to 2 decimal places in percent, then it is 15.87%. If you're told to write your answer in decimal to the nearest 100, because that's what my lab maths ask this kind of question all the time. Be careful. If you're told to leave your answer in decimal to the nearest 100, it just means 2 decimal places. It means if you're told to leave your answer to the nearest 1,000 and answer in decimal, 1,000 means 3 decimal places. So your answer will be 0.159. So just be careful, read between the lines, because you'll be taking a test in my lab maths. You'll be taking the pre-test. Actually, the reason for the pre-test is to make sure you are ready for the test. You know how to take a test in my lab maths. Okay, so we have calculated the area. This is a question that people always ask. I don't know how to use my calculator. So that's why we use the first half of the class to say it. And now we actually did this one the other day, but it's number 24. So 25 actually is what we planned for today. Now, let's make sure we remember how to do 24. It says an insurance company crashed 4 cars in succession at 5 miles per hour. The cost of repair for each of the crashes was this. Complete the range. The sample, I mean, I think